Hello everybody, my name is Anthony Moran and today Tarndeep, Matthew and I are going to present our final project for Command Shift Arcade Game Room. Okay, on to the what and the why of our application. So our original idea was to build a classic arcade game such as Space Invaders or Pac-Man. Unfortunately, I remember the original Atari console games in the late 70s and was curious to see if I could code them myself. However, after the first week of research, we decided against these games due to perceived complexity and compatibility with our experience level and time available. Most of the game tutorials were built with technologies such as Phaser and Unity, and we wanted to build with vanilla JavaScript or React. Most importantly, we wanted to do a game because we thought it would be fun, and it was. After a week or two, our project developed into a full web application with multiple games integrated within the app. This allowed us to use front-end and back-end more extensively. We wanted to develop an application that enabled a user to select a game from the application using a carousel. We also wanted to create a back-end that allowed for user login, logout, user authentication and high-score leaderboards that would be saved and retrieved from a remote database. Early problems that we wanted to solve in our proof of concepts included: could games even be built in JavaScript and React.js? Could we build an app in React Native for iOS and Android and deploy to the web? Could we build games with our level of experience? Game functionality such as collision detection also had to be solved with our POC. Basic mock-up of games like Flappy Bird were developed to prove out these issues.
For the main React website, we chose Vite over the traditional Create React app. This is because Vite is much faster as it uses ESBuild instead of Webpack, which is much quicker and can improve the performance of projects. Vite's hot reloading feature allows you to see changes to your code without having to restart the development server. This saved us a lot of time when developing our application. To create the game carousel, we first created an array of objects which contained all the relevant game information. We then mapped through to create the game page and thumbnail carousel. The carousels use the swiper library to create responsive sliders and display the games. This way, it makes it easy to add or remove games as required, as we only need to update this array containing the game information. The games themselves are embedded in the site using the HTML iframe tag. One of the challenges we faced when building the website was how to take the score from an iframe and access it in the React Vite website. We tried using local storage and cookies, but due to browser security measures, we were unable to access the scores from any site that wasn't the same as the website of the game. We resolved this issue by using the window.postMessage function to post the score to the React website, and then having an event listener on the React website listening to any data sent to it. When data is sent from a game to the React website, this indicates a game over and triggers a score to be submitted. If no nickname has been set, there is a prompt asking the user to create one. If one is created, the score will be submitted, otherwise there will be an error message saying the score has not been submitted.
Technologies we used for the front end included React, React Native, vanilla JavaScript, Netlify, Axios, Expo HTML and CSS. After research, HTML5 Canvas was chosen due to its performance and being well suited to graphic-intensive games. A lot of the technologies we used were due to ease of use and familiarity. This was true of Netlify and Vite, where both Tarndeep and I had used them before for other applications. We were also keen to use technologies that are used in the real world for employability. React being a good example of one of those technologies which is popular and widely used in industry. We'd also learned some of these front-end technologies on the Command Shift Bootcamp, and so it made perfect sense for us to use them again for our project due to limited software development time.
Front-end technologies we used that I worked on are Firebase, which allowed for authentication of the users, and using Google as a sign-in method. Let me save the URL of the profile picture to local storage and use on the scoreboard. As mentioned, I used local storage to save profile picture URLs and also nicknames for users to customize themselves. Web storage is more secure than cookies, and large amounts of data can be stored locally without affecting website performance. Axios was needed for async functions that get and post to the backend for the scoreboards.
So my first game, Tetris, was built with React using hooks and React components. In this Tetris component code, we have several important aspects to highlight. We have React hooks on lines 18 and 19. The useState hook is used to manage state variables, the first variable being the drop time, or the rate at which the tetramino shape falls. And we also have game over state. Custom hooks lines 22 to 24, use player, use stage, and use game status are used to manage specific aspects of the game logic and state. Examples include position, tetramino shape, and collision status for use player, updating the stage such as clearing completed rows for use stage, and calculating the score for use game status. The Tetris component is the main component that holds the game logic and renders other components. It imports and uses various components such as stage, display, and start button to create the game's user interface. The game logic is quite simple. The move player function is responsible for moving the player left or right based on user input. The key up function is triggered when a key is released, and it handles specific key events like releasing the down arrow key to activate the interval again. The start game function handles the dropping of tetraminos, checks for collision and game over conditions, and updates the game state accordingly. The drop player function is called when the arrow down key is pressed and drops the tetramino faster. The move function is triggered when an arrow key is pressed and moves the player left, right, or rotates the tetramino. There is a use interval custom hook that is used to handle the interval for dropping the tetraminos automatically. It invokes the drop function on a specific interval, which is drop time. User interface and styling. The game UI is wrapped with Style Tetris wrapper and Style Tetris components to provide styling. The stage component renders the game grid, and the display component shows the current score, rows cleared, and level. The start button component is used to start a new game.
One of the first games we developed was an endless runner type of game where you have to jump over and roll through enemy slimes. It was built with vanilla JavaScript, HTML, and CSS, and the HTML5 Canvas API. We wanted to make this game feel unique, and rather than copy someone's code or code along with a guided tutorial, we decided to use assets from itch.io. Itch.io is a platform for game developers to share and sell their artwork and game assets. Using these assets presented us with new challenges for our game development process, and we needed to understand the logic behind the code to make necessary adjustments and amendments and add our own features such as high scores, game over, and restart menus. For the second game, I originally wanted to build a beat-em-up arcade game, such as Streets of Rage, and I first made a simple game using blocks to see if it was possible to calculate hitboxes and hit detection. From this, I realised that it would be very difficult to build a beat-em-up style game in the limited time we had, and so decided to make a local cooperative two-player fighting game instead. So two-player local co-op, also known as couch co-op, is a type of multiplayer where two players can play together on the same console or computer. And this game was built with vanilla JavaScript, CSS, HTML5, and the Canvas API. I also used green sock animations for features such as the health bar. I found a guide online to use as a starting point, but it was based on the older JavaScript syntax, and it lacked many key features for the game to be in a playable state. I didn't want to rely on existing guides and tutorials, so whilst building the game, I made the decision to update the older JavaScript syntax to the new JavaScript ES6 syntax. The use of modules really helped with the overall quality of my code and made it more readable and easier to maintain. It allowed me to structure my code effectively and make it easier for others to understand. I was also able to add many features that made the game feel more balanced and fair for both players.
The back-end technologies I used for this part of the project included NPM, which was used as the package manager. Express.js is the back-end framework that helps manage servers and routes. CORS, cross-origin resource sharing, was used to allow requests from the front end to the database. Postman, to manually test GET POST requests for the front end to use. .env, used to assign environment variables. Node.js to locally host, and NodeMon to re-render when an update is made on the code editor. MongoDB is where the data for the scoreboards is kept. Mongoose to create a schema for the data added to the database. And I used onRender to host a dynamic web page for the backend. The backend was used to get the scoreboard data to display on the front end and allowing adding to the database from the front end also. For middleware, I used built-in express.json that parses an incoming request object and recognizes it as a JSON object. I also used Helmet to control response headers, which by default hid a header called x_by from response headers for the client, preventing some common vulnerabilities for Express web frameworks. With the REST API representational state transfer in mind, I used uniform resource identifiers for GET and POST requests. For example, the GET request for each game will be an abbreviation of the game such as run for endless runner game, and the POST request is done with a /add amended to the end. The schema for the data sent is defined with Mongoose. Here you can see I've set the name and score with the option to send a URL of the logged in user profile picture, or will default to an anonymous image. Date is also kept track of with a default option of now.
For our application, we use the Agile software development approach. Because we were all working on different parts of the application, team communication and agreeing the design specification early was key to the project's success. To achieve this, we held regular meetups with the Around app due to its unlimited time restriction. One session we had was around 10 hours long, so we needed this functionality, and it had to be free. We firstly developed an outline design specification using Figma prior to writing one line of code. Only after agreeing the spec did we start writing code individually and as a group in our mob programming sessions. We held regular stand-ups and retrospectives, which were always positive, apart from me mainly worrying that we wouldn't finish on time. We made extensive use of GitHub for version control and collaboration. We set up GitHub so any merges to the main repo had to be reviewed and approved by 2 other team members. We used Trello for our Kanban boards, which was made up of assigned tasks in categories such as to do, in progress and completed. We also used Slack for meeting minutes, progress updates and urgent actions.
Challenges I faced on this project were deploying the backend as onRender, where the backend was hosted, and MongoDB, the database, needed to be from the same region. This required me to delete and recreate the database on the MongoDB that could match the region of the deployed backend onRender. Firebase was a new technology for me and was a challenge to implement, but I knew it would be important to have an easy way to submit images to the scoreboard, as well as help with other plans we had for implementing users' profile pictures. Playing audio with React as examples I found were using Vanilla.js or old React component did mount, where React hooks were more in line with other components used in the project. While I did get the audio playing, I ended up creating separate instances and was not ready to implement. If I had more time, I would work on refactoring the backend as I focused on readability when creating the Mongoose schemes and the routes in the backend.
While studying on the bootcamp, we have primarily been using Jest. However, there have been some issues with Jest when used with Vite. One of these issues is that Jest does not support hot reloading, which is a feature of Vite that allows you to see changes to your code without having to restart the development server. To overcome this, we looked into using vtest, which is a new testing library that's designed specifically for Vite. Unfortunately, due to being unable to invest the time and resources to learn the vtest framework, we were unable to implement TDD into our project. We do understand the importance of TDD, and if we could go back, we would put much greater emphasis on it and ensure we had implemented it into our project.
I would like to thank all the tutors at Command Shift for their total support during the last 6 months. Their help and words of encouragement were vital to getting me through this bootcamp. I'd also like to give a special thank you to Tarndeep and Matt, who are 2 of the most capable junior software developers on the bootcamp. I was truly very fortunate to have them as project team members, so thank you.